Hello students, this is your SDsir again from the Temple of Excellence, Vidhyaashram Pre-University College. Hope all of you have thoroughly revised Coulomb's law and whatever concepts we learned in association with Coulomb's law. In my today's session, dear friends, we will highlight, we will discuss, we will understand a very significant topic, something called as electric field. We will understand what actually is an electric field. We will understand the definition of a very important term called electric intensity, and we shall also understand the concepts related to electric field and electric intensity. So we now start understanding what is meant by electric field. Before I go into depth understanding what is an electric field, I would introduce a very important term, something called UPC. And this term UPC is expanded as unit positive charge. U for unit, P for positive, C for charge, a commonly used term in the entire study of physics. UPC, unit positive charge. What does this mean? We all know unity is 1, so 1 positive plus charge represented by C. Therefore, students, any charge whose magnitude is plus 1 coulomb is referred as a unit positive charge. Commonly, what I will be stating as UPC. So, summarize, I commonly use a term UPC, unit positive charge, which is a charge whose magnitude is plus 1 coulomb. Now, with reference to this UPC, unit positive charge, we will understand something called as electric field. My dear students, in general, what does this word field signify? Field andreno, some space or some region. For example, battlefield where the warriors fight, playfield, space where kids play, region where they play. So the word field in general means some space or some region. Then what is an electric field? My textual definition says it is a space or region surrounding an UPC. Very beautiful. Some space or region which surrounds an unit positive charge surrounding an UPC, which means to say, suppose I call this UPC, unit positive charge, there is some space or some region which surrounds this UPC, and we say this space or region is called electric field. So we understand any space or region surrounding a unit positive charge is called electric field. But my practical assertion here is, how much of space surrounding the charge I can call as an electric field? Can I treat any space, any magnitude of region surrounding the charge as an electric field? No. Here it says the charge should experience electrostatic force and electrostatic influences within that electric field. The charge should feel electrostatic forces and electrostatic influences within the region called electric field. Now, how do I understand this concept? Here is a UPC, a unit positive charge, which is surrounded by a certain region, what I call as electric field. Now, what should the electric field do? It should exert some force on that unit positive charge. The UPC should feel some electrostatic influence because of this field. Meaning to say, the field should exert some electrostatic force on the charge. Because of that, the charge may rotate inside the field. Because of the force, the charge may experience a torque. Because of the field, the charge may gain some potential energy. Only if these impacts happen on the charge due to the field, due to the region, then this field is termed as the electric field. So, to go back again, we say the space or region, some space, some region which is surrounding an unit positive charge, where the electrostatic influences should act on the charge. The electric field should exert some electrostatic force. There should be some rotations, some torque, some potential energy due to that space. Only then I call that as electric field. Now, suppose I consider one more charge here. There is some space or region surrounding this charge. Now, this electric field is not termed as an electric field to this charge. Why? Because this charge is not under the influence of my concerned electric field. It doesn't experience any impact due to this electric field. Therefore, this field is not an electric field for my second considered charge. See, for example, there are two classes happening. In room number 81, a physics class is happening. room number 82, a mathematics class is happening. Room number 82 is not considered to be the field for the students in 81. Why? They are not under the influence of the mathematics teacher. They are the influence of the physics teacher. The physics teacher is having an impact on students who are present in room number 81. So room number 81 becomes the electric field for the students there. Similarly, room number 82, the students are under the impact, influence of the mathematics teacher. So 82 is the relevant field and not room number 81. Therefore, we clearly learn that if any region or any space has to be treated as electric field, then it has to have electrostatic influences on the charge. The field has to exert electrostatic force on the charge. Because of that force, electrical impacts are seen, and that is what we call electric field. Therefore, to revise the definition of field again, it is the space or region surrounding an unit positive charge where the charge experiences electrostatic force and electrical influences because of that field. Now, dear students, continuing further, a very important term, very important term called electric intensity. Yen intensity andre? Generally or commonly we use this word intensity. What do I mean by intensity? What is being intenseful? The simplest word I can correlate with intensity is being forceful. Something which is forceful. He is very intense in nature. He is very forceful. Then what is this electric intensity? Now, we told there is a unit positive charge, a UPC, and there is certain space or certain region surrounding it, what we call as electric field. But under what criterion I can call that space or region as electric field? Only if this region is exerting some force on the UPC. ಹೇಳಿದ್ವಲ್ವಾ, electric field ಅನ್ನಿಸ್ಕೋಬೇಕಾದ್ರೆ that region has to exert some electrical force on the charge, and the simplest understanding says this electrical force itself is what we call as electric intensity. So the definition says electric intensity at any point of the electric field. You consider any point within the electric field. Andre, you place the UPC wherever inside the electric field. It should experience some electrostatic force, and that electrostatic force is what we call electric intensity. ಹೇಳಿದ್ನಲ್ವಾ, intensity andre force. Wherever inside the electric field, you place the charge, it should experience some force, and that force itself is called electric intensity. No exaggerations. So please to understand here afterwards, the force acting on a UPC at any point of the electric field is what is called electric intensity. Electric field ಒಳಗಡೆ ಎಲ್ಲೇ ಯು ಪಿ ಸಿನ ಪ್ಲೇಸ್ ಮಾಡಿದ್ರು ಅದು ಫೋರ್ಸ್ ಎಕ್ಸ್ಪೀರಿಯನ್ಸ್ ಮಾಡುತ್ತೆ. ದಟ್ ಫೋರ್ಸ್ is called electric intensity, or dear students, it is also called electric field strength. Strength of the electric field. How much of force is exerted on the UPC? Magnitude of the force acting on the UPC. That is what we call electric intensity. So my physical definition says it is the amount of electric force acting on a unit positive charge placed at any point of the electric field, and it is also termed as electric field strength. So mathematically we write electric intensity, force on there. So it has to be a vector. So vector E is the force acting on the charge which is placed in the electric field. So it is vector F divided by Q. Force acting on the charge placed in the electric field is what we define as electric intensity. And be very careful, electric intensity is a vector quantity and it's SI unit. First main examination, any SI unit may be asked for 1 mark. So the SI unit for electric intensity is Newton per coulomb. Newton, why? Because force unit is Newton, charge unit is coulomb. Newton per coulomb is what is giving me the SI unit of electric intensity. And later in the potential chapter, I will also show that intensity is measured also in terms of volt per meter. So it is a vector quantity. It has an SI unit Newton per coulomb, or which is also volt per meter. So now we have studied 2 definitions here. The first definition for electric field, which was the space or region surrounding an UPC, where UPC should feel electric forces, electrostatic influences. And what was electric intensity? Very simple. Force that acts on the unit positive charge placed at any point of the electric field. Within the electric field, any point you place the charge, it will experience some force, and that force is what we call electric intensity. Mathematically, E equals F divided by Q, force acting on the charge. It is a vector quantity whose SI unit is Newton per coulomb or volt per meter. Now, dear students, we go up to a very important bookwork where I calculate electric intensity due to a point charge. Electric intensity due to a point charge. Have earlier told point which is very, very small. So intensity due to a point charge, because of a point charge. Now, to begin with, I will consider a point charge plus Q, which is my point charge, plus Q. So plus Q is the point charge which is placed at the point O, and the medium in which it is placed is air. Andre, this is the air medium, free space. Here I consider a point O, and above this point I am placing my charge plus Q. So plus Q is the point charge which is placed at the point O, and which is the medium in which it is placed, free space, air medium. Now, my dear friends, there is some space, some region which is surrounding that point charge, and that space or region we call as the electric field, discussed earlier. I will consider one more point P inside the same electric field in the same air medium. Some other point P. P is another point inside this field in the same air medium, which is separated by a distance r from the point O. So O was here, P is the point here, it is separated by a distance r. R is the separation between the point P and the point O. What is placed at P? 1 coulomb UPC. Significance of this slightly next I discuss. A charge of plus 1 coulomb UPC is placed at the point P. So my initial considerations very simple. Which is my point charge? Plus Q. Where is it placed? Point O. Which medium it is placed? Air medium. Where is my UPC placed? At the point P. What is its distance from O? It is R. Now, what should happen to this UPC? It should experience a force because of this point charge. Very clearly see, intensity due to a point charge. The UPC should experience some force because of the point charge plus Q. And what was that force we called? I learned force acting on the UPC in an electric field is what we call as electric intensity. Therefore, electric intensity due to a point charge. I repeat, my point charge plus Q will exert some force on the UPC within the field, and that force is what we call as electric intensity vector. And I say it is acting along OP. How did I assign this direction? Very important. Know this, students. Especially while working out problems, you require these directions. At the point P, there is a UPC, positive charge. At the point O, point charge plus Q. Both of them are like charges. Whenever there are like charges, there are repulsion going away. Please to understand, wherever there are like charges, wherever there is repulsion, force or intensity, listen carefully, force or intensity acts away from the charge experiencing the force. I repeat, wherever there is like charges, there has to be repulsion. And now force or intensity will act away from the charge, experiencing the force. So which is the charge experiencing the force? UPC. Which is the charge exerting the force? Point charge. So the force or intensity should act away from the UPC because it is experiencing the force exerted by the point charge. What if one is plus and minus? Slightly when we go to the characteristic of field lines, you will know that. Now please to understand, like charges, repulsion, force acts away from the charge experiencing the force, as in this case, which is UPC. So intensity is acting away from the UPC. Now my task is to calculate how much of force is exerted by the point charge, or what is the magnitude of electrostatic force between these two charges. And how do I do that? Do I know any law? Yes, I have described Coulomb's law. Coulomb's law gives me the magnitude of electrostatic force between any 2 point charges. So here again I use Coulomb's law to calculate the magnitude of the force between the point charge and the UPC. And you know, since both of them are placed in air medium, force is 1 by 4 pi epsilon naught Q1 Q2 divided by R square. If it was a material medium, epsilon, but generalizing air medium, the two charges are placed in free space. Force is 1 divided by 4 pi epsilon naught Q1 Q2 by R square. Now what is this Q1? It is the magnitude of my point charge, the first charge, plus Q. What is Q2? Magnitude of the second charge, UPC, 1 coulomb. And what is the distance of separation between them? R. So it is 1 by 4 pi epsilon naught Q, magnitude of the first charge, into 1 magnitude of UPC divided by R square, which is 1 by 4 pi epsilon naught Q divided by R square into R cap, which is a unit vector. So what does this expression give me? That is the expression for force acting on the UPC because of the point charge inside the field. And what did we call that force as? It was nothing but intensity. So I have computed the expression for intensity. So we write intensity is always 1 by 4 pi epsilon naught charge divided by distance square. Magnitude of the point charge divided by distance square. Kindly note this. Most of the times you go wrong by writing Q divided by R, which is potential. Electric intensity is always 1 divided by 4 pi epsilon naught Q divided by R square into n cap. Why n cap? Make it vectorial on both sides. N cap is the unit vector which is acting along the direction of OP. So what is important for me is the expression for electric intensity due to a point charge, which is 1 by 4 pi epsilon naught Q divided by R square. And how did I compute that? It was by using Coulomb's law, where I evaluated the electrostatic force between the point charge and UPC. Q1, Q2 by R square, Q magnitude of the point charge, 1 magnitude of the UPC, or distance of separation. So please do keep in mind electric intensity is formulated through a very basic relation, which is 1 divided by 4 pi epsilon naught Q divided by R square. Continuing further, students, this is the heap of my discussion. Probably to understand things simple and better next, I should also know these relations, these topics, very, very important. Here, I am highlighting about 2 terms. One, what I am calling as the source charge, and the other one, what I have called as the test charge. Follow, dear students, source charge and test charge. What is the meaning of source? Something from which we get padkolodu. Sun is the main source of energy. We get things from the source. And what is the source charge therefore? Now I consider a point charge plus Q. Immediately there is a space or region surrounding it, what I call as electric field. From where did I get that electric field? Was it in air? Was it in free space? I have got that electric field only because there was a point charge creating that field. Source, creator, and therefore this point charge now I call as the source charge because it is the source of this electric field. I repeat, I could get this electric field. This electric field could be created only because I had a point charge plus Q. It is creating the electric field. It is the source of the electric field, and therefore we call it source charge. Source charge. It is a charge which is creating the electric field. Therefore, any point charge which creates the field, electric field, is what is called source charge. Then what about test charge? As the name itself says, test charge. Now I told, if this field has to be called electric field, I need some electrostatic influences. How do I test the electrostatic influence? I will place a UPC at some point inside the electric field. What is this UPC plus 1 coulomb charge doing? It will test the effects of this electric field. How much of force the field is exerting on that charge. How much of potential energy is acquired by the charge inside the field. How much of rotation may happen due to torque, which means the entire effects or impacts or influences caused by the electric field is tested by this UPC, and therefore I am calling it unit positive charge to be the test charge. So beautiful words: source charge, test charge. So what is source charge? Something which is creating the electric field, something which is the source of the electric field. A point charge which gives me the electric field is what I call source charge. What is test charge? Always it is UPC plus 1 coulomb of charge, which will test, which will give me the impact of the electric field. So here afterwards, very clear: source charge, test charge. Point charge creating the field is the source charge. UPC testing the effects is what we call as the test charge. Now, very clearly, my question is, I have a practical ambiguity here. I have an UPC plus 1 coulomb of charge. Certainly, it is also a charge. So, will not there be a field around the UPC which will add to the effects of the existing electric field? I repeat the question. I have my test charge, UPC, magnitude 1 coulomb. Will it not have an electric field around it which will test or add to the effects of the existing field? My dear students, that is why I say I use UPC as the test charge. The magnitude of my test charge is very, very small. Very clearly, the magnitude of the test charge should be very small so that it will not affect the existing electric field. So now you understand why I told UPC is always considered as a test charge, because its magnitude is so small that it will not affect the existing electric field, and therefore always source charge is the point charge creating the electric field. UPC is the test charge testing the electric field. Why UPC is the test charge? Its magnitude is very, very small so that it will not affect the existing field. Which means now what are the factors on which the strength of this electric field depends upon? I've clearly told Mr. UPC has no contribution to the strength. ಪ್ರೇಕ್ಷಕದು ಅಷ್ಟೇ ಸುಮ್ಮನೆ ಇರುತ್ತೆ rigid. Then what does the electric field strength depends upon? It depends upon the magnitude of the source charge. I have more money, I give you more money. I am rich. I am poor, I can donate less. So if the strength has to be more, ಸಾಹೇಬ್ರು ಶಕ್ತಿವಂತರಾಗಿರಬೇಕು. So the point charge should have sufficient magnitude to create a strong electric field. And then it also depends upon the distance between the source charge and the test charge. So what are the two factors which will contribute to the strength of the field? It is the magnitude of the point charge, the source charge creating the field, and the distance between the point charge and what we call as the test charge. Now, again very important, ask for 1 mark frequently in the exam, you have to draw the nature of electric field in case of a positive point charge and negative point charge. So first, I consider positive point charge plus Q. You can see some lines which are depicting the nature of the electric field. What is the nature of the lines here? Observe, the arrows are showing outwards, going out from the charge. Therefore, we say for positive point charge, electric field should act radially outwards. Please keep in mind, positive point charge, electric field acts radially outwards. We say here the electric field starts from the charge and ends up to infinity. It is going out from the positive charge. So please do remember, for any positive point charge, electric field acts radially outwards from the charge. It goes away radially to infinity. And for a negative point charge, you see the direction, the arrows coming in, they are acting radially inwards. So electric field acts radially inwards when it is a negative charge. So please to understand, if it is a positive point charge, electric field acts radially outwards. The direction of the electric field is radially away from a positive point charge, radially inwards if it is a negative point charge. Now, as a conclusion to this session, remember my assignment day 1, force between multiple charges using Coulomb's law. How many of you have done that? Question yourselves. Again, on the same criterion here, one more assignment to you all. You will calculate now electric intensity due to a system of charges. Again, due to a single point charge, 1 by 4 pi epsilon naught Q by R square. Now, if I consider multiple charges, system of charges, the assignment for you all is to compute the electric intensity. Hope you do this, students. I believe you have followed today's session. Definition of field, where the space or region should have an impact on the charge. Definition of intensity, which is simply the force acting on the charge in the field, expression for intensity due to a point charge, and very important consequences, source charge. Source creates the electric field, point charge. UPC tests the electric field, test charge. Why only UPC? It is a very small charge in magnitude. It will not affect the existing field. Students, hope before my next session you come prepared, thoroughly revised for next class. Revise today's session. Have a great day. Thank you.